Okay, hello, Assalamualaikum and good evening. Good evening. How are you? Can you hear me?
Waalaikumsalam.
Thank
Can.
you. Yes, fine.
Okay. As we already, I think we already very what we call that last week. So last week, since this originally this session is coming from the 01G, and the 01G is actually almost 60, okay, 60 students. So that's quite heavy for the lab session, basically. So that's why it is separated into two. So I'm the one who will lead the 0G one. 0G is very ad hoc. Uh, I'm also shocked and surprised also. All of a sudden, I was appointed to teach this subject. I think I taught once, last two semesters maybe. Uh, so basically, the pattern of this course this time, though we are lab lab course, but for the case of motor control, in this semester we are only proceeding it to the simulation base lab. Okay, simulation base. So if compared to the experimental base lab courses before, so it requires a lot of hard works, hardwares and hard works, struggles, sweats. Okay, but this time since we are using only based on this machine, I mean the laptop, so there will be no sweat. There will be no sweat or wiring. There will be no wiring. There will be no the real magnetic contactor. But I try to maybe I try to set maybe one or two classes that or some videos we show the original what we have in the FTKE. I mean the motor control one. If we have chance, okay. So in our class maybe there will be two hybrid also, maybe synchronous and also asynchronous. Not all the weeks, not every week we have class like this, okay, because there's part that, for example, I'm teaching you the components, and for example the DOL, direct online, and after the direct online we go over the forward reverse bias, then after that you are given several, maybe around 2 weeks maybe to finish up your task and submit the report. I think we are going to that pattern lah. Now we are not finish one subtopic, then there's the project, the lab report. Okay, there will be the lab report. Then after that class maybe after explanation, then you are given time. Means that there will be no synchronous session for several weeks, 2 to 3 weeks maybe, until you finish the report, you submit the report, then we proceed to the next step, next chapter, for example, auto transformer or star delta, like that. Okay? Or you still want to, yeah, Loi Fuichi, yes.
So sir, I would like to ask, is that we are just based on the using simulations, or we've got a chance to
To go.
assembly the instruments like
Oh,
that?
so okay, semi the instrument. Okay. Uh, okay, like this. Most cases, all assessments, the project report will be based on the simulation base. Okay, simulation base. Actually, we have the simulation software. We call that as EKTS. So in the subject, so instead of doing that wiring stuff, the motor, the play with the magnetic contactor and so on. For the case of the assessment, so you are doing the simulation called EKTS. So you study how to do that, how to run that, and you submit the report. Maybe at the end of the session or the weeks, maybe I try to slot in that we can visit join Gambang kan. So we go to the Gambang part. There's a motor control. There's a DOL, some DOL, but they want only for the sake of teaching only. You can touch it, but no assessment. Understand? Okay. We can go there.
Okay,
We see the
understood.
DOL. You still can uh, touch it, play with that. Maybe for 1 week, one class or two class only, just for your experience. Just for it. But for the sake of the For the case of assessment project report will be based on the software. Okay, boleh.
Okay, faham.
Okay.
So, thank you.
Alright. Okay. Oh, saya belum start lagi. Pun dah lama. Okay, saya pergi slide. So I'm going to the next slide. So this is the 1961, the code for the subject motor control. So this course exposes students to various type of three-phase induction motor starter circuit. The student also will learn about the principle of electrical motor and its protection system. This course will be the last for the batch of EC and EA20. Okay, EA20 is the last batch who use this lab. For the EC21, start from batch 21st, there will be no subject motor control like this, but it will be embedded on the separate lab session. I think the lab course, lab 1, 2, 3, 4. That one maybe will be involved in two lab, other lab lah. But that one only focus on the lab. So we don't have that one credit lab course anymore for batch of 21st. But for you, batch 19 and batch 20 or batch 18, you have this kind of, you still need to go through with this subject lah. Because the content, to be honest, the content in this subject is old school because we use DOL, star data, star data, auto transformer like that, which is old school type of the three-phase induction motor based motor one. In electronic drive is the most latest one, I think. We are using, the electrical motor, DC motor, something like that. This is for the three-phase based motor, induction motor. So very old school. Okay, but we still need to finish it. Okay, motor control. Alright. So this course, blah blah blah, is about the three-phase induction motor starter circuit. So the student also will learn about the principle of electrical motor and its protection system. So there will be two course outcome which is tagged to the PO5 with the psychomotor. Though we are using the simulation, is still called appropriate tool, something like that. Still relevant. Okay, the first one demonstrate the function, types, and components of electrical motor and motor starter circuit with awareness of safety and professional ethics. And second one, construct different method of motor starter circuit. This is what you are going to do using the EKTS software. So you draw the circuit, like that. And then this the map, the PO, program outcome. This is underlined by the EAC. EAC, the Engineering Accreditation Council. We have the 12 POs or program outcomes. One of that is PO5. PO5 will be tagged in the psychomotor or modern tool usage. So create, select, and apply appropriate techniques, including prediction modeling to a complex engineering problem with an understanding of the limitations. So it's about getting to the prediction and modeling also. Can also to modeling, not really modeling lah. So we try to model the DOL, the star data in the software. Okay. And then the assessment. Okay, we have basically maybe I promise this is only assessment we have. We have laboratory. Laboratory. Yeah. We have 4 lab reports. Okay. Project is actually assignment. Sorry, ni lain sikit. Ni assignment. This is assignment. Sorry, forgot to replace this about assignment lah. Assignment super easy. Assignment is super easy, writing like that. They're related to the motor, and we have laboratory. We have 4 lab sheets. We have 4 lab reports. Okay, that lab report we also call project report, but the one is in group. Okay, we have 30. So you are going to be divided with several groups. Okay, several groups. 10 groups is the maximum one because we have 30. If I'm not mistaken, you have 30 in total. Divide into 3. 10 groups 10 groups maybe. So each group will have 3 members. So means that all that report will be divided into 3 lah, the distribution of the work. So you're not doing alone lah. You're not doing alone. Even though software, I think the software is not that very difficult like Simulink or MATLAB. I think it's very clear cut software. I think 3 of you will be more than enough lah So four titles that cover for that report. Okay, I think the first one is DOL. Second one is first one is components. Doesn't need the EKTS. Second one is the DOL and for reverse bias. They one need to use the EKTS. Second one is the star delta. Third one is the star delta. And the fourth one is the auto transformer. The auto transformer also just the rating lab sheet. No need for the EKTS simulator because it's not capable using the EKTS for the auto transformer. I think only 2 lab report that use the EKTS. So now it's getting better. It's getting lesser. I mean the load. Then quiz we have four quizzes and will be in Kalam lah. I will update time to time about the quiz. Okay. And the project is actually assignment. Saya tak nak potong lah ni. Assignment 20%. And the test is the written test. So we are going to do at the end of the last week, maybe week 13 or week 14 for the test. Written test lah. We don't have the practical test because everything simulator. So it's evaluated on project 2 and project 3. I mean the laboratory 2 and laboratory 3. They're using the simulator. So we evaluate only based on rubrics. So we don't have the practical test for this motor control anymore. So the test will be on written lah. I'm not finished yet. Okay, this all about assessment. Okay. Any question about assessment? For the quiz, don't worry. I'm not going to do during the class hour only. No. That's not my type. I don't like that kind of quiz that only do in the class. So I open for 2 days. So you can assess within the 2 days in the Kalam lah. Nanti banyaknya lecture buat macam tu kan. Any question about the assessment?
No, sir.
Sir, about the project, we are in group, right? So we have choose our teammates or sir will arrange for us.
Okay, which one do you like? You want me to arrange or you want to decide by your own?
Decide by our own.
Agak dah. Ada group? Bashar Abdullah.
Yes, sir.
Which one will you prefer? You want me to arrange the group for all of you or you want to decide by your own? The group
You,
members.
sir.
You,
sir.
Me?
Yes.
Me decide? Oh, you are going to regret that. Don't regret. If I decide, you don't regret. I think I will blast the Google form and you choose your own members. Okay? You can choose your own members. 3 members per group. Okay? Is it okay?
Okay.
But if Bashar still want me decide, then you need to pay me. No. You can choose your own group member lah, senang. I think that's easy for you to do work, to adjust your own time. Maybe you want to discuss. It's okay for you lah. It's up to you, so you decide. I will give within this week. I will give some G form or before next week lah. Sorry, within this week I give promise lah. Before next week lah, I will form the form group, Google form. Then you can choose your own lah. Okay loh Fuji.
Alright, understood. Thank you, sir.
Suka dah tu. Okay, I think let's start a little about the introduction of the motor control. Very simple and very straightforward. And also I already uploaded the slide. That's why I'm telling you that in this motor control version, I mean the simulation version, if you read on the slide, you can finish several, I think 2 hours finish already. All reading and you finish within 2 hours. Because in physical, you are going to take 1 hour, 2 hours for assembling, wiring, installation. looking for the magnetic contactor. We play with that. Then motor control is broken. Change between that. Then you quarrel with each other. Kan? That's why it takes time until several weeks to finish it. But when you go to simulation, it's definitely become very, very super easy. And if you read, trust me, if you read without stop, 2 hours, finish all. Seriously. That's why we are going to do step slow by slow, slow and steady, and don't get too pressure with this. You should enjoy it. Okay. Wait, Oh, there's Azan now. Can I stop? Pause for 3 minutes? Okay. Pause. 3 minutes.
Okay, sir.
Azan. Okay. Sorry. 3 minutes. Okay. Let's continue. Before 5. We finish before 5. Okay. Right. Motor control system. What is motor control? I think you can read, but still, I still want to teach. Okay. Not really teach, maybe reading. Motor control is about the way how we design and construct the circuit to control an induction motor in terms of beginning, starting the operation, and stop the operations. We have the motor, and we need to control the motor. That's why we're saying that this is motor control. So that control, this kind of control, is not based on the electronic based control. It's about the hardware based. Okay. Like the mechanical term, there's mechanism to control the circuit, okay, to control this motor. Okay, there are 2 types of circuits that we have to design and construct, which is the first one is the power circuits, and the second one is control circuit. Okay, so the main motor that will be used here, focus here, is the 3-phase induction motor. Okay, the 3-phase induction motor. Okay, the 3-phase induction motor. So an induction motor, or we call that as the asynchronous motor, is a type of alternating current motor where power is supplied to the rotor by means of electromagnetic induction. So the induction is coming from the electromagnetic one. After the motor is supplied, okay, by the power lah. Okay, the current is injected. Okay, due to their simplicity, robustness, and cost effectiveness, induction motor are the preferred choice of industry. Again, due to their simplicity, robustness, and cost effectiveness, induction motor are the preferred choice of industry. Okay, very simple. Very simple. Why we need to control? It's like saya pause like orang. Okay. There's issue of induction motor. There's issue for induction motor. Common issue. The first one is during startup. Okay, during startup, they develop currents of up to approximately 8 times the rated current, and the starting torque linked to this. Okay, means that during the starting is the highest one. The current spike. Okay, can go until the 8 times higher than the original rated current of that motor. The spike at the first during starting. That's why the mechanical starter, the startup to quite consume lots of energy, quite consume a lot of power, because they produce very high current. That's why sometimes the old school type, not the electric vehicle, I think the all stuff of motor, the engine itself, during startup also, if we jump our battery at the startup only, not during the operation, only the startup, because at the first starting the jet generator, it consumes a lot of current, okay, a lot of energy during the initial part. Then after that, it becomes stable and it comes to the rated current. So that's one of the common issues of the induction motor. Okay, the high starting currents often lead to unwelcome voltage drops in the supply network, and the high starting torque put the mechanical elements under considerable strain. So the higher starting currents lead to unwelcome voltage drop. There will be the drop of the voltage in the supply network, and the high starting torque put the mechanical elements under considerable strain. Okay, how to control the motor? Okay, that's the issue lah. Can read it back. So that's one of the issue. High starting current. Okay, high starting current. That's the main lah. Okay, there's two types. There's several methods to suppress. Okay, to suppress this issue, or to control this issue. Limit the values for the motor starting current in relation to the rated operational current using the following method. Okay. The first one is the full voltage. We call that full voltage. Apply full supply voltage to the motor during start. Okay. Apply full supply voltage to the motor during start. We call that as the direct online, DOL. Okay, direct online. I think the direct online also for the old school air conditioner. Old school air conditioner, they have the switch with the green and the red. The green and the red button. All type of the air conditioner, they're not using inverter yet. They're using the three-phase. I mean the bigger size of the in the office, in the government, in the many office, a lot of office in school or in company, something like that. The old school type. Until the inverter air conditioner is coming, we're still using the mechanical switch that have the green and the green and the red button. There's two buttons there. That's type of the direct online. Very old school. Okay. But now we are going to the smart one. Okay, we have the inverter, we have the smart air conditioner, something like that. So now that's why I'm telling you this kind of subject is already, for me, it's outdated. Because we don't use anymore this kind of application. We don't use the DOL type of the air conditioner. The old buildings, they still use. But now, we are using the inverter-based air conditioner kan. So when the inverter-based air conditioner, they don't have this kind of high starting current. That's the advantage of the inverter. That's why that can suppress energy consumption during starting current also. And we use the inverter, there's control there, which is very smarter than this other type school of the motor or air conditioner, three-phase air conditioner. Okay. So the first one, direct online. Second one is the forward reverse. Okay, forward reverse bias. We are going to go detail after this. Just the headline. Okay. So this is based on the full voltage. Apply full supply voltage to the motor during start. Full supply voltage. Okay. Second one is the reduced voltage. So apply reduced supply voltage to the motor during start. Apply reduced supply voltage to the motor during start means it's not the full voltage lah. There's a certain value, 1/3 or half, something like that, to supply voltage to the motor during the start. The first one is full voltage, full drive. Second one, the reduced voltage. Okay, that one is the application for the star delta and auto transformer. Okay, auto transformer control circuit. Okay, right. So we're going to the motor construction. Okay, motor construction. I think for those who haven't, some of you are from the diploma. I think you have the diploma. I think during the practical, your industrial training in your previous institution, maybe you go already industrial training for 6 months. I think for 6 months maybe. Semester. Maybe there's some place, there's some student maybe have a chance to work on the industry that maintaining the motor, something like that. So maybe they get used with that already. Or you already learned in the electrical machine, okay? Electrical machine. Or even in the electric drive also. Okay? Okay, this is stator. We all know already, stator is the stationary part of the motor. Stator lamination are stacked together forming a hollow cylinder. Coils of insulated wire are inserted into slots of the stator core. Okay, stator. The stator windings are connected directly to the power source. So this the windings indirectly. This the applied voltage is here. And the power is applied at this region. Each grouping of coils together with the steel core it surrounds become an electromagnet when current is applied. So we apply the current to it, okay? Apply the power to it, so it induce comes the electromagnetic and it will induce, okay? When current is applied, the electromagnetic is there, okay? The stator is made up of a number of stampings, okay, number of stampings with slots to carry this phase winding. It is worn for a definite number of poles, okay. There's three phase here, phase 1, phase 2, and phase 3. We don't have the real thing in front of us, so just imagine okay. The windings are geometrically spaced 120 degrees apart, okay, the windings. And then two types of rotors are used in induction motors. Okay. There's we call that squirrel cage rotor and one rotor. This is detail. You can see different. So that's the stator lah. You can read detail. Did my do my webcam start ke saya punya kamera kenapa saya macam dia rasa macam dia freeze sikit ni.
Ada
Freeze dah.
Dia macam robot sikit dia tak ni
Lagging saya.
lagging aduh shit betul kacau betul. Okay, sama juga tak banyak sangat AV. Tak berhenti tutup sekejap. Okay, sama juga. Sama juga, biarlah. Okay, the rotor. So the rotor is the rotating part of the electromagnetic circuit. It's in the middle one, called as the rotor. So the most common type of rotor is the squirrel cage. Okay, squirrel cage rotor. The construction of the squirrel cage rotor is reminiscent of rotating exercise wheels found in cages of pet rodents. Oh, ini ada pet rodent tak ni? Exercise wheels found in cages. Saya pun tak tahu pasti masuk ayat ni. Apalah, baca je lah. Okay, the rotor consists of stack of steel lamination. Okay, stack of steel lamination with evenly spaced conductor bars around the circumference. So the rotor lamination lah. But the important thing is we have the rotor, we have the stator. The detail also you can Google lah, ataupun mana motor jumpa kau buka lah. Okay. So lamination are stacked together to form a rotor core. Okay. Rotor core. So this is the steel lamination. Okay, ni nampak. Steel lamination. Aluminium is die cast in the slots of the rotor core to form a series of conductors around the perimeter of the motor. Okay. Where's the aluminium? The conductor one. Okay. Current flow through the conductors form the electromagnet. Okay. Current flow through the conductors, and then electromagnet. So the conductors bar are mechanically and electrically connected with end rings. Conductor bar is the conductor bar. Okay. Yeah. Electrically end rings. So this is the end rings. And then the rotor core mounts on the steel shaft to form a rotor assembly. Okay, this is the shaft. Okay, so this complete the rotor part lah. Okay, so the detail you can Google lah. I think don't ask me detail lah. I didn't establish the motor by myself. Okay, kita tengok ni. Okay, this motor fine. Okay, this is motor. Alright. Oh, lagging lah semua. Stress lah ni. Okay. Okay, enclosure. The casing. Okay, the enclosure consists of frame, yoke, and two end brackets, bearing housings. Stator is mounted inside the frame, or the stator inside the frame. The enclosure part is the outer part is the enclosure, and you have the stator. The rotor fits inside the stator with a slight gap separating from the stator. Logic kan? Ada gap lah between the rotor and the stator. Of course lah. That's how we can rotate. If touching, there's nothing happen lah. Okay. There's no direct physical connection between the rotor and the stator, of course lah. If not, then the motor cannot move, cannot rotate. The rotor cannot rotate. The enclosure protects the internal parts of the motor, blah blah blah. Bearings mounted on the shaft support the rotor and allow it to turn. Tahu kan bearings ada kat situ. Okay. Support mounted on the shaft, not on the core part of the rotor, but it's in the shaft. Okay, bearings here lah. Okay, bearings here. In the middle, they are not touching to each other. Only the bearing that touch to the enclosure. Okay. Fan also mounted on the rotor shaft to cool the motor when the shaft is rotating. So we have the cooling fan at the back side of the motor. Okay, back side of the motor, in order to cool down the whole motor lah, from overheating. What else? Motor when shaft. Okay, ni ada nampak lebih clear. They are more clear than this. Alright. So we can see this we have the connection box and terminal box. Where's the supply is coming here. Power supply is coming here. Tap. Okay. Then stator core. So this is the stator core. Stator winding. This is the winding. And nameplate. Nameplate not the important. Then they will have the base. They attach to the anything else. On the ground, on the floor. Then this is the squirrel cage rotor. This is what we call. It's all about we call as the squirrel cage rotor. Okay, and this is the bearing. And the bearing is at the edge of the shaft. Okay, near the shaft to support the rotor to rotate, so that it can rotate. Bearing. So this is the squirrel cage rotor. Baca je lah. Okay, baca lah sikit lagi. 10 more minutes. Okay. Alright, the concept of the how motor works. Any question? Even you have question, you read for yourself.
No, sir.
Even you have question, keep it and you read. Okay. Alright, this pause pula lambat lah. Lagging lagging. Spoil. Okay. So again, this is 3-phase induction motor. The rotation of the rotor is coming from the electromagnetic field that exists or that produced by the applied of the power or current throughout the stator, the one. Okay, we apply the current there, then electromagnetic field exists. Then after that, the rotation is coming from there. And the rotation or the the stator is connected to 3-phase, because there is 3-phase based on 3-phase induction. In the following instruction, phase A is connected to phase A of the power supply. Okay, so I mean the plate for each phase tu, the part for each phase tu is in opposite way. Okay, for example, we have the A1 and A2, so the B2 and B1, and the C1 and C2. Okay. What else? Between the C1 and A1, between the A1 and B1, between the B1 and C1 is differentiate with the 120-degree phase. Okay, it's not the same. We don't put A, B, C at the same time, at the same place. So we purposely divided into three, then that's the meaning of the each face is different with 120 degree. That's why the direction like that. Okay, see it? A to B1, A1 to C1. It's all divided into three. So it's 120 degree phase difference. So that's why the phase current, the phase is it phase current what? Okay, the phase rotation. Okay, this is the 120 degree. Okay, that's why each phase is different with the 120. Okay, like this. Okay, this phase and this phase is differ to. Okay. Oops. So this phase A and this phase B. Bro. Okay. It's differ with 120 degree. And the B and the C also same. It's differ with the 120 degree. So this full cycle and this full cycle. This is of course halfway. Oh sorry, tak nampak sini. This is halfway kan, 180 degree. Okay, this is the meaning. So the phase first is applied differently. So the three-phase motor, you must use the three-phase power supply lah, of course lah. That's why I'm saying this about the air conditioner old school type, but the big one that 2 above, I think 2 horsepower above of the air conditioner. The example of the old school type of air conditioner that use this kind of mechanism, this induction motor, very old school. Now we are using the inverter type. Okay. So phase B and phase C will also be connected to the phase B and C of the power supply respectively. Okay. This is AC power supply. The following instruction, phase A is connected to phase A of the power supply. Okay, like that's the direction. Maybe red, yellow, blue. Okay. Phase A maybe red, yellow, blue, depends. Lagging. Okay. 6 minutes I use 2 for each of the 3 phases. Nampak tadi kan? So there's 1, 2, 3, 4, 5, 6. Okay. So 6 minutes 2 for each of the 3 phases. The coils are wound around the soft iron core material of the stator. I think the person were very detailed in the coiling and magneting, and the coiling concept is Dr. Mawadi. If you know Dr. Mawadi, is very detailed with the electromagnetic study and very detailed about the coiling. I think windings, how many windings, the most expert person in this faculty, so in this program, I think Dr. Mawadi, if you know him, okay, who are teaching you electromagnetic field theory, EMT. Okay, when current is applied, each winding becomes an electromagnet, becomes an electromagnet, with the 2 windings for each phase is operating as the opposite ends of one magnet. Okay, 1 magnet. So there's 2. Okay, there's 2 windings for each, 1 and 2. The A1 and A2. See, A1 and A2 with the opposite direction. Current applied, each winding becomes electromagnet. Each winding becomes electromagnet with the 2 windings for each phase operating as the opposite ends of one magnet, north and south. One winding is north pole and the other is south pole. Maybe the first one, A1 is north. The second is the A2 is the south. Okay. The stator is connected for 3-phase AC power source. And then okay, winding A1 and A2 connected to phase A of the power supply, and B1, B2, of course, phase B, C1, C2 connected to phase C. So coils A1, B1, and C1 are 120 degree apart, same like above. Windings A2, B2 also 120 degree apart. So they correspond to the 120 degree separation between each electrical phase. That's the what we call that, the coordination of each phase for A1, B1, C1, and so on. Okay, the direction of the motor, so the direction of the stator. So the current flow direction, like this. For the first one, the first one, north, south. The first become north. So for the A2, become south. Rotate, okay. Mana ni? Reading A1. So A1 north. Okay, and A2 south. Okay. So this is the terminal lah for each motor lah. Okay. And then how the current flow direction lah. Supaya you baca ulit ni. Sikit lagi. So start phase A is no current flow and its associated coils have no magnetic field. Phase B is current flow in the negative direction and phase C is current flow in the positive direction. Okay, I mean the first one, phase A. Okay, phase A, no current. Okay, phase A no current, and then phase B negative. Phase B negative and phase C is plus or positive. Okay. Based on the previous chart, B1 and C2 are south pole and B2 and C1 are north pole. Okay, B1 and C2. B1 and C2 is south pole. B1 and C2 south pole. B2 and C1 are north pole. Negative. Again. B1. Pening aku. Okay. B1 and C2. Okay, B1 and C2 negative. Okay. And then C2. Okay. Sorry. Okay. So ni C now minus. C now. Okay. So B1 and C2. Okay, C is minus now. And look at the B1 and C2 are south pole. So now B1 negative. Okay, because B is negative south and then C is positive. So that's why both are south. And then B2 and C1 are north pole. Okay, B2. Okay, B2. Because the phase B is negative. Okay, phase B is negative, both B1 and B2. So that's why B2 is north. Okay, B2 is north and C1 okay, C1 is also north. Okay, right. So magnetic lines of flux leave the B2 north pole. Okay, leave the B2 north pole to the south. Okay, between the pole and enter the nearest south pole. Okay, B2 go to the nearest C2. Okay, enter the nearest south pole, which is C2, which closest the things that closest to the B2. The B2. Where's the B2? B2 is here. Okay, the B2 is here. Okay, the B2 is here. Wait, the B2 is here. Okay, so it will go to the nearest. So the B2 is here. See, this B2. Okay, it will go to the south one. So it will pick the closest south one. Closest pole is the C2. Okay, C2 is the closest one. The B1 is quite far, but the first one will go to the C2. So the B2 will go magnetic line tu flux go from B2 to C2, and then magnetic lines of flux also leave the C1 Knox pole. Okay, the C1's Knox also will go to the nearest path for him, which is the B1. So the C1 will leave the magnetic flux will leave from the from C1 to the B1. That's why written here lah. And then you can read, okay, C1 to the B1, B2 will go to the C2. Okay, so the bottom sum of the magnetic field is indicated by the arrow. So the direction of the motor will go on the right direction, the right direction. Okay, as you see from here to here, from left to the right. Okay, that's the direction for the first one, for the start. Okay, for the start. So the following chart shows the progress of magnetic field vector as each phase is advanced 60 degree. Note at the time phase C is no current flow and no magnetic field, blah, 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 blah. And then you go through one by one for this case. Because for example, this one, now the A become positive. Okay, the C becomes 0, which nothing put to the C. B is still minus. Okay, B is still minus. So we go next. You can refer to this table, then you understand the current flow direction will be like this. Okay, like this. So it's clockwise. Okay, if you see from here, so the rotation is clockwise. Clockwise direction. Okay, clockwise direction. Alright, you can read. Okay, so at the end of 6 such interval, the magnifier will have to rotate one full revolution of 360 degree and it will return back to normal. So this process repeats 60 times a second for 60 Hz power source. Okay, for 60 Hz power source, so it will rotate 60 times. For 50 Hz power source, it will rotate 50 times a second. Okay, alright, okay, right. Go one by one if you want to go to detail, if you want to understand the mechanism of that. That's the thing. Read one by one and you can understand. This is example the start, and then you follow the numbers 1, 2, 3, 4, 5, 6. So we rotate in the clockwise direction. Okay, Fana Fazli. Fana Fazli is missing. Hazwan. Hey, you guys can hear me?
Yes, sir.
Yes, sir.
I thought
Can hear you.
freezing, screen freeze, semua senyap. Pengacau. Brianda, okay, Brianda.
Yes, sir.
Okay, understand?
Yes.
Yes. Okay. I know. Now it's your tea time. Wait. 5 minutes. I promise I'm finished. Okay. So next is the motor nameplate and terminals. Very super simple. So this is the terminal. Okay, the old school type of the motor, the 3-phase induction motor. You can see here is blue, green, okay, this white, and so on. And then this nameplate. The nameplate usually outside of the box they have the manufacturing and rated volt, blah blah blah, full load, frequency, rated power, full amps. All motor should have this kind of things. If you try, for example, if you have the IED project, you want to use the simple motor, maybe. So make sure the motor has this kind of, at least this kind of full amps. How much is it? Rated voltage. Same with other motor also, DC motor, server motor. Most of the important things, please check at the rated volts. Okay, rated volts. For example, you use Arduino, and Arduino for the device for 5 volt. So you need to find the servo motor that if you direct connectly to the Arduino, for example, you must find the motor with the 5 volt. Don't use the 13, 12, 9 to 12. Okay, if you use the 9 to 12, maybe you need to another one auto coupler, something like that, to boost out or converter, so that it can work on the and then, or you use the motor driver, something like that. So make sure, simple thing, don't make mistake. Okay, red volts is very important, depend on your application, and full load amps, how many amps it can goes. Okay, 3 amps, 6 amps, like that. And then the rated power, what's the maximum power of that? How many watt? 12. Typical value of the motor rated power, I think 12 watts, 12 watts, 15 watts, 18 watts, sometimes 30 watts. Sometimes for the pump, 60, 30, so they have. Okay. And electrical connection, however, power factor. Okay, for the three-phase induction motor, they are written there. For the DC, not written that kind of power factor because there's DC, so we don't need that power factor only for the AC. Okay. Then motor maintenance, induction motor by their very nature require very little maintenance. However, regular regime of inspection is recommended to ensure minor problem do not escalate to breakdowns. Most cases, I think they're brushing, they check for the critical part. There's industry also who maintain, who doing the service, cleaning service of the motor. I think there was one student I know, he did the industry training in the place, small industry, but they are opening the motor and change the brush, do the coil of that. So very critical work actually, very expertise, I mean very technical. Change until open the casing and then take out the rotor, remove the windings, replace with the new windings, complete cleaning, and close it back, return back to the industry. Because service motor, I think, is of course cheaper rather than you buy the new one. Okay, different intervals will be 2,000 hours of operation of 3 months, whichever is the sooner. Okay, motor maintenance, physical damage, accumulation, no significant corrosion, rusting, then corrosion, excessive vibration, no loose fasteners, cables, earth, sound, sealing of the blah blah blah. Okay, and fault finding and recognition. Okay, fault finding, motionless, soundless, possible causes, fail to start without load. I think this is very technical. If you go with the listening, you work with the motor, then maybe you see it here. For me, you just read. It's not coming out in the, I'm not sure. It's not coming out in the test. I'm not sure. Okay. Like, I think even you read, you can understand. Me also, I don't understand if I don't do involve in the practical way. Yeah, that's, if you involve in the practical way, that's more easier for you to remember by your hand. Okay, not remember by your head, you will forget. But remember by your hands, automatically your psychomotor is working by himself. Okay. Blah blah blah. Fuse blowing, fail to start due to trip off. I think this is the mechanical works lah. Mechanical to technical. Under voltage, over voltage, check circuit capacity, power source, you get it lah. Okay, loading after start, very noise. What is the reason of the noise? Loose coupling or skipping. It's all about maintenance work of the motor lah. Okay, it's mechanical vibration and symmetric centers. Same like fan, the stand fan. The stand fans, if the fin, if the fin once broken, you will see the very extreme vibration, because it's not stable. It must balance between left and right. Okay, annoying gambar ni. Stop. Tutup kamera jap. Okay, so this is just the technical things lah. Usually for the works who are working on that, I think that's enough for you. Just read just like that lah. No need to memorize. It's not that critical for you to memorize. Last. Janji lagi. I give promise and again I break promise. Last. Only for the safety. Very simple again. Simple thing, but still I want to show you. Even uploaded already, but still first class I want to show you. Okay. Same like I think low voltage integral installation also the same. So safety precaution labs, make sure environment around workplace is clean, wear suitable clothing, not too tight and not too loose, wear shoe, having thick and all around seal sole, when they blah blah blah. Wearing slipper is strictly prohibited. Let's imagine that we are now in the lab. Okay, when now in the lab, then you need to wear the shoes, wear the proper suitable clothing, not too tight or not too loose in the lab. Don't wear slipper. Okay, equipment used must in good perfect condition. Actually, most of the cases is maintained by the lab helper. But also sometimes maybe they overlook of that, or sometimes maybe student already broke it, so you then have to take it off lah. If dah rosak tu tinggal je lah kan, no need to use that one. So just call the person in charge and finish. Okay, after you go must be kept original place, blah blah blah. Okay, like please wear shoe in the labs, blah blah. Okay, safety precaution in labs. Nobody is allowed to make joke. Joke tak boleh lah. Boleh lah joke sikit-sikit, simple. Or playing sharp instrument. Okay, don't do that lah. Object with friend while doing wire work. Make sure cable connector used fulfill its SAE rating. Though you are not doing the lab, let's imagine you are in the lab. Okay, make sure every electrical installation have effective earthing and avoid it from rust. After using electrical machine, it must be switched off. Any addition of circuit must be avoided unless you are given permission from the person in charge. Okay, do not dismantle, of course, a system from the in charge. Must solve before testing the experiment with electrical supply. Of course, we need expert to do that. Don't work on your own. Open the switch and it will explode. Okay, first need to check by the instructor and the lab assistant lah. Okay, something important for must be switched off before fitting sockets. Okay, outlet switch must be off condition. Basic lah. Okay, other reminder, wearing slipper, no jeans. No jeans I think sometimes in the company they use jeans also but please don't wear jeans lah. No long hair for men. Okay, no long hair. University je lah kan. No cameras. Okay, no cameras. Don't do TikTok atau live Facebook. No, it's not. It's prohibited. Not too tight, too loose clothing. Just wear the proper clothes. Don't wear clothes like you're going to the, to the kenduri kahwin ke. Janganlah. Okay. Jacket, strongly recommended, blah blah blah. And then hat ni kita jarang ada. Earplugs ni pun we are not working in the heavy industry, so we don't use earplugs. But goggles also we are not playing with the welding. But doing the motor, so I think that's the minimum risk lah. Using the assembly motor, there's no spark there. But if we play with the turn on, if you start to turn on the system, the motor, then maybe you need the goggles lah. If something happen, explode, spark coming out from there. So no ring on finger, no rings, it can electrocute you. Okay, electrocute yourself if you're by unlucky you touch the conducting leakage material like that. So you're going to see the heaven maybe. Okay. Wear PPE, but it's not PPE for COVID. It's a PPE for the lab and the sewer. So exact current, safe current values is actually milliamps or less. Milliamps very small. Okay. Playing with the battery actually is we play with the amps, not only milliamps. Okay. Even the milliamps already has already very dangerous. For example, 8 milliamps can make you painful shock. Can let go at will since muscular control is not lost. 200 milliamps. But imagine if the current is amps, so cannot imagine what will happen to you lah. Please don't play with the PPE. Okay, make sure auxiliary off, arrange all tools and component in proper manner. Good practice motor control, read carefully, design both skirt, go to skirt, arrange the tools and component properly, wire up, blah blah blah, quality test and so on. Get permission from starter and apply power supply. Okay, I think that's all. Any question? Very boring in the tea time, during the tea time, sorry to exceed the time from what I promised. Any question?
No, sir.
No.
So far, so good, sir.
So far so good Okay. Ain, ada any question? Nurul Ain Alia Zawawi. Panjang. Nurul.
Yes, sir.
Any question?
No.
No, of course I know. In my class, I like to pick up name, so please get used with that. Just itulah, elect je lah, okay. Just the last. Nur Izzati, any question?
No, sir.
No. Okay. If no question, then see you next week. Any updates, I will inform in the WhatsApp and also up in Kalam. Okay. I already upload several slides. Okay, already have the slides there. You can refer. But first, last but not least, I think you can start to find the software. We call it as EKTS. Okay. Okay. Please find the software. Try to open, play with that. Okay. We are not going to the assessment yet, but please just try to download and look at the YouTube, something like that. Okay. Just to play with that. Okay. All right. Thank you. See you next week. All right. Dismiss.
Thank you,
sir.
Okay, dismiss.
Thank you, sir.
Okay.
Betul.
Thank you, sir.